In this video, you will see my students summarizing chunks of information by discussing concepts with a partner. Please note, the hand motions seen are a whole brain teaching strategy to help keep my students engaged. They are not a part of the numbered head strategy.
Hands and eyes. All right, so when we talk about tides where we see the biggest tidal range from the difference between the high tide and the low tide, we're talking about a spring tide. And then that's when the earth and the sun are in a straight line with the moon. If we have a full moon, which is on the other side, the sun, if you look at your definition, tides are caused by the gravitational pull of the sun and the moon, right? So you have the sun pulling in one direction, the moon pulling the other. There's nothing pulling it above it, below it, which is why we're going to get a strong tidal difference. But if we look at a new moon, they're both where?
In the moon. They're going solar from the sun. I mean, from the earth.
Yeah, they're both pulling from the earth, right? So they're both on the same side. So it's kind of like being a tug of war. It's kind of like an unfair tug of war. There's nothing pulling on this end. There's only pulling on this side. So you're going to have the strongest tide. But does anybody recall from the video, the brain pop video, why it's bulging on that side as well if there's nothing on this side to pull it? Do you remember? It's also pulling what? Yeah, it's pulling the earth itself. So you've got this big bulge of water from the tide, and then you've got the earth being pulled as well to the center of that, which is why you're going to have the greatest tidal range. So the way to help you remember this is think of someone on a spring, okay? So I want you to imagine being on a spring and you're getting really, really low, and then you're going to bounce really, really high. So we're going to have the highest high tide and the lowest low tide. So to help you to remember is think of a spring that is bouncing from low to high. But it only happens if everything is aligned, and that is the earth, the moon, and the sun. Mirror words. In a spring tide, we have the highest high tide and the lowest low tide. James, join us, buddy. We have the highest high tide and the lowest low tide, like bouncing on a spring. This is in a line. So we need the sun and the moon and earth to be in a line, playing like tug of war. So in a spring tide, we have the highest high tide, the lowest low tide, because they are aligned. All right, number ones, you're going to teach number twos anything that you've just learned about spring tides. When I say teach, you say okay. Teach. Okay. Number ones on the left, go. Talk to number twos about spring tides, go. Why? Why is it spring tide? Tell them more. She's learning it. Class? Yes. All right, number twos, you're going to do the same. Teach number ones what you know about spring tides. When I say teach, you say okay. Teach. Okay. Okay. Go. Number twos. Talking about two different types. This first type that you've discovered has the largest tidal range is a spring tide. So skipping one line in your notes, what are the types? How many of you have ever gone to bed before and like the air conditioning has broken? How do you sleep in your bed? With no blanket, right? And then what does your body look like when you're on the bed without any air conditioning? Show me. Sideways. Yeah, sideways, spread out, right? You want to just not be on top of yourself, right? So you're going to want to spread out. So molecules like to do the same things. They like to expand as much as possible. And to help you remember the word expand, I want you to make your body into the shape of an X. So like if you're really hot in bed, you're expanding the shape of an X. So that X is going to help you remember that molecules like to spread out, hands down. All right, so mirror with words. When molecules heat up, they get very excited. And they start to move. And they start to spread out. And they expand. So molecules, when they heat up, they get very excited. They start to move really fast. And they expand. All right, so hands down. When we are able to expand in an object, sometimes we change the shape of that object as well. All right? Number ones, number head. Raise your hand if you're number one. I want you to teach number twos about what happens when heat is added to molecules. When I say teach, you say okay. Teach. Go. Number ones. So what happens when heat is added to molecules? What else? Can you do hand motion? Class. Okay, so expansion happens because those particles are moving as fast as they can. So I've got a container right here, and I've got a kettle of water that I've just boiled. So if you see me pour it in there, you'll be able to see some steam coming off of there. Okay. Now I have an empty bottle that has a balloon attached to the top. This has been sitting at room temperature. So I want you to watch as these molecules get very excited and I place this container in this boiling water. Watch the balloon. Just holding it so it doesn't tip over. So the molecules inside that balloon are getting really excited. And show me with your body, what do? Expand. So the balloon is expanding because all the molecules are pushing on the outside edges of that balloon so that they are trying to move away from each other, okay? So expansion happens when heat is added. So I'm going to take that out. Now the opposite is going to happen when we remove heat, okay? So this is going to be where we get is contraction. So I want you to imagine you're in your bed this time. The air conditioning is not broken, the heat is broken. And you don't have a blanket. So how are you going to sleep now in your bed? Right, you're going to curl up and get really, really close to each other. Some of you get cold in class, and what do you guys do if you're cold in class and wearing your short sleeve shirt? What do you guys like to do? Yup, pull your arms inside, right? You want to pull your bodies close together as possible. Well, the same thing happens to molecules. When they cool down, they're not excited and spreading out. They're slowing down, and they're pulling closer and closer together until they have contracted. So it's the opposite of expansion. So we get the removal of heat, so it feels colder. Those molecules are contracting. So I want you to think of like a curled up cat. Everyone make a curled up cat. So we're making the letter C because now we're contracting in those molecules. Mirror with words. When molecules lose heat, they contract. They pull close together, making an object smaller. When atoms or molecules lose heat, they feel colder and they get closer together so that they contract. This is the opposite of when heat is added and molecules get excited and they expand. So again, molecules, when they lose heat, they contract. Get really close together. Number twos, raise your hand. You're going to teach your group about what happens when molecules lose their heat. When I say teach, you say okay. Teach. Okay. Go, number twos. What happens when they lose heat? All right, so let's talk about the difference between the two. On Earth, people tend to use mass and weight interchangeably, but they do not mean the same thing. Mass cannot change no matter where I go in our universe. Mass literally means the amount of matter inside. So if I'm looking at me, if I weigh 100 pounds, then I have 100 pounds worth of matter inside me. That is the amount of stuff that I'm made up with. Mirror with words. Objects. or matter are made up of atoms. If I look at how much is inside, that is mass. Because mass is the amount of stuff inside, or the amount of matter inside. And it does not change. Mass does not change. It's the amount of stuff inside. All right, number heads. Number ones, you're going to talk to number twos about what mass is. Go. Feel free to use those hand motions. Mass is what? Class, class, class. So again, mass cannot change. It is the amount of stuff inside, or the amount of matter inside of an object. All right, let's get that in our notes. Skip one line. Mass is the amount of matter in an object.
Try to remember to use distributive summarizing. It should happen all throughout your lesson. If you present your content in smaller chunks with a variety of learning styles, your students will better assimilate and retain the information you teach. One of the ways that you can summarize is by using numbered heads. It is a cooperative learning strategy that holds each of your students accountable for learning the material. This cooperative learning structure helps ensure that all your students are thinking, saying, and or doing.